Hello students, welcome back. So now we are going to talk about different data types in Verilog. So in this video we are going to talk about that what are nets and registers. We will also talk about integers and real data types, non-integer data types also, and we will also touch that what are strings in Verilog. So basically we are going to talk about that what are the different categories or types of data that we can use for defining different signals, registers and wires in a Verilog program. So let us get started. So Verilog data types, the data types make our design, our description, what we call as RTL description, much easier to write and understand. In Verilog, we are having basically two categories. The first one is nets. Nets are basically wires. Wires are used to carry forward a signal from one point to another point. This is what we use wires for in real world also. We have maybe a voltage or current and that is carried from one point to another point. And the second one is registers. Registers are our storage elements. We are going to hold those variable values. So if I am doing some computation and my result is 5, I need to store it somewhere. So that is where we will use these registers. But when I am computing, I am passing my computation results from one point to another point. That task is done using the nets or the wires. So this is the main difference between these two categories. So let us talk about nets now. Nets represent the physical connections. I have an ALU, then I have a register, or then I have a flip-flop. I need to connect these structural entities, and wires will physically connect these structural entities. Except for the category called tri-state register, wires will not store the values. Some of the examples in the nets are wire, tri-state, wire with OR, tri-state with OR, wire with AND, W AND, tri-AND means tri-state wire with AND, tri-0, tri-1, supply 0, supply 1, and tri-state register. Among all of these, wire is the most frequently and popularly used type, and we use the net data type when the output of some device is driving the signal. The signal is declared as an input or the in-out port. In that case, we use wires. So basically, we will use them mainly on the input side or in between the computational stage. The second is register. Registers are the variable that will hold the value, that will store them. They are used in the procedural assignment. We'll talk about different styles or different categories of Verilog assignments in our next videos, our next module. And when the signal is on the left hand side. So whenever we assign, there are two sides, left side and right side. Left side is always the side where we will assign or allocate. So registers will be on the left side. The assignment statement can change the value of data which is stored in the register. The examples are REG for register, integer, time and real. Among these, register is the most frequently used, and we can use REG for describing the logic, integers for variables and arithmetic computation, real for decimal point calculations, and time is mainly used for storing the simulation time. We are having two pictures here. The first one is a wire and the second one is describing a register. The wires are net 45. net 67, net 11 or net 9 and net 2, which are connecting different structural entities and they are not holding any value. But on the right side where we see register, there is a 4-bit register or 8-bit register. That means we can hold 4 or 8-bit data in these registers. Now, when we know that we can hold some values, then we should also know that what are the values which are possible to be stored. So there are 4 possible values. 0 means logic 0 or false, 1 means logic 1 or true, and then comes 2 interesting values. X means unknown. That means we have not calculated anything or assigned anything. And Z means high impedance or tri-state. That means infinite resistance is not allowing the current to flow. So it is also called high impedance for the same reason. So that is represented by Z. This usually comes after the calculation, and when we see that a correct calculation is not possible, then we assign Z. We have the categories called integers and real data types, and here we have integers which are bit, byte, short int, int and long int. Bit is a single bit value, byte is 8 bit, int is 32 bit, that is the standard integer. Half of it, that means 16 bit, is short int, and double of it, that means 64 bit, is called long int. So this is how we can store the values using these categories. Then we have Verilog strings. Strings are stored in the register data type. Strings are basically characters which we define. Like if I want to say hello world, so how do I store hello world? It is not an integer. It is not logic 1 or 0, right? So then we use register data type to store these strings. Strings can contain multiple characters or single character, and for every character we allocate 1 byte of memory. So if my string length is 10 characters, then I need 10 bytes of memory to store the complete string. If the memory allocated is not adequate, my length is 10 but I am allocating only 5 bytes, then the Verilog will truncate the bits from the left side. And if we allocate more than the required memory, we are allocating 15 bytes for a 10 byte requirement, then additional zeros will be added. So let us have a look at this example. Here we have a string called learn Verilog. So here we have 5 characters in the word learn, 7 characters in Verilog, and there is a space in between. So 5 plus 7 plus 1, total 13. So we are defining a register 8 into 13. 8 bits into 13, that means 13 bytes. If we define 8 into 10, then 3 characters will be lost. And if we define 8 into 20, then 7 zeros will be appended. So this is what happens in Verilog with strings. So students, now we know about different data types also. We are going to talk about very interesting topic, and that is called module instantiation in our next video. Keep learning. Thank you.